What's up mga ka-che? It's Kuya Dale here. So I'm back with another Che Calc lesson, and I hope you loved the previous lesson, which is about the concentration, and I hope you were not mind boggled with the units that I have used in the problem. So now we'll talk about primarily about temperature, but the highlight of this lecture will be on how to convert the units of the temperature. Also, the main application of that will be the conversion of the units of heat capacity. So from English to SI and SI to English. So that will be the content of this lesson for today. Okay, so let's start this lesson. So temperature is a measure of the energy, mostly kinetic, of a molecules in a system. So why is that? Because when you have a high temperature, so high temperature, the molecules of a in the system will be so excited, so they are really energized. So one way to measure the energy of that is through measuring our temperature. Okay, and then for the next definition, the property of the state of thermal equilibrium of the system with respect to other systems, because temperature tells us about the capability of a system to transfer energy as heat. So one way to illustrate what it is saying here. So for example, you have two objects here are in contact with one another. So we have a, for example, this object is hot and then this is cold. So the transfer of energy will be from hot to cold. So that's the spontaneous um, pathway uh, of things. Okay, so heat really goes from hot to cold, and then it needs such time that the temperature or the energy transfer will equilibrate. Okay, so the temperature will not be uh, the energy will not be transferred anymore because this has lost heat. Okay, and then it was transferred to the cold object, and such time and that they will be in equilibrium with each other, so they have the same temperature. So that's one way to that's the indicator, or that's the indicator that the two objects are in thermal equilibrium with one another if they have the same temperature already. Okay, so that's it. So that's the property of the state of thermal equilibrium. Okay, so it tells us where if uh, two objects in contact with one another are already in thermal equilibrium. Okay, so we have the units of temperature. So we have degrees Fahrenheit, English, English, and then for Celsius, we also use it in both actually, uh, and alternatively, uh, degrees Celsius is also called centigrade. And also we have a Kelvin, which is the absolute temperature scale. Okay, it also can be solved from Celsius. Okay, this is in the SI unit. Also, this is also in the SI. And also degrees Fahrenheit, it's the absolute temperature scale of the English units. Okay, so we have these uh, four units of temperature. Okay, so to convert between them, so we have we just have to use these conversions. So from to convert uh, Fahrenheit to runtime, you just have to add 460, and then to convert the Celsius to uh, Kelvin, you just have to add 273 to it, and then to convert your degrees Celsius to degrees Fahrenheit, just multiply the temperature by 1.8 and add 32, and then you just have to do the opposite if you want to convert back. And then there's also a quick way from Kelvin to Rankine. So to convert uh, this Rankine, from Kelvin. So just have to multiply it by 1.8 also. Okay, so that's one way of um, uh, converting. Okay, and then I have also included tables here from our series. 10 table 1-7 and table 1-11 from 8th ed, and go check it out in your free time so that you will not you can find this there actually, the conversion between units that I have presented here. And then if you want to uh, find the shortcut of it in your calculator, so I also provided here shift 8 and then just type in 37 or 38 depending on what you want to have as a result. Okay, let's not waste time there. So let's solve some sample problems. Okay, so complete the following table with the proper equivalent temperatures. Okay, so just have to convert from degrees Celsius. So degrees Celsius, just have to convert it to Fahrenheit, to Kelvin, and then to degrees Fahrenheit. Okay, for example, we want to convert it to degrees Fahrenheit, you just have to multiply it by 1.8, right? 1.8, then add 32. Okay, and then the answer is actually negative 40 also degrees Fahrenheit. Then and trivia, this is the only uh, value that the degrees Celsius and degrees Fahrenheit are equal. Okay, so equal sila. So uh, if you want to convert it to degrees to Kelvin, okay, just have to add 273 to it. So negative 40 plus 273, the answer is 233 Kelvin. Okay, and then to convert it to Rankine, actually we have two options. So we will add one is to add 460 to our degrees Fahrenheit. So just have to add 460. So will be 420. Okay, 420 degrees runtime. And then the other way is to multiply 1.8 to our uh, Kelvin value. Okay, so 233 will come out as 420 degrees runtime also. No, but not really a exact value, but still it is near. Okay, so we just have to put here our answers. So 40 and then 233 and 420. Okay, so I will do all the rest. I will not show the solutions anymore. I will just show you the answers. Okay, so here is 25, and maybe you can do this in your free time. Just pause the video uh, so that you can practice with me. Okay, so here is 425, 797, and then 1257. Okay, and then 234.6, negative 390.2, and then we have 38.4. 38.4. Okay. Okay, so let's move on. Next, so the heat capacity of sulfur is Cp, so equals 15.2 plus 2.68 times T. So where Cp is in joules per gram mole per Kelvin and T is in Kelvin. So convert so that Cp is given in Cal per gram mole per degrees Fahrenheit with T in degrees Fahrenheit. Okay, so actually we can just the caveat on converting these types of equations is we can convert it right away. We have to do some adjustment first because the Kelvin in this case here is not really the temperature Kelvin. It's actually the temperature difference. So if you want to have the temperature here, so let's say for example 298 Kelvin. Okay, in Kelvin, this is not actually what the units here indicate. It actually indicates temperature difference. So for example, uh, we have uh, 298 there as our initial temperature, and then for example we have a final temperature of 300. So we'll have to uh, subtract 298 from it, so that will have 2 Kelvin. So actually to differentiate, we'll have to denote it by delta Kelvin, but uh, there are many in the books they don't really put it there, but just be reminded that the K here is not actually the temperature itself, it is the temperature difference. Okay, 198K is different from the 2K difference. Okay, so it is actually the temperature difference. So knowing that, you can solve our problem. Now, the easiest way to convert this is to picture where we're going. Okay, so we are our goal is to go to our goal is to go to calories per gram mole per degrees Fahrenheit. So we'll convert the units. So just we will create a conversion factor. Okay, so gram mole per Kelvin. Okay, so we will convert that to into grams per calories per gram mole per degrees Fahrenheit. And remember, this is actually delta degrees Fahrenheit. It is not actually the degrees Fahrenheit alone. Okay, so joules. So we'll convert that uh, for 1 calorie. It is equal to 4.186 joules. Okay, and then uh, to convert the degrees uh, temperature difference, we'll just have to have these conversion factors. Okay, this is in your pairs. Actually, you can find it there. Okay, so to convert from difference nga k, it's just k there, and then we multiply 1.8 to the degrees Fahrenheit. Okay, this is found in your Paris conversion. So we will not add 32 to it yet. Just we can do that later. Okay. So to this, we can have our conversion factor as let me write it in fraction form. It is 2,500 over 18,837. Okay, so store it in your calculator, maybe in A. So store it in variable A, and then we'll multiply it by the whole expression or in the whole equation. Okay, so 15.2 plus 2.68, and remember this P here is in Kelvin, so we'll have to convert that later. Okay, we were asked for P in degrees Fahrenheit. Okay, so pk, and then we will multiply that by 2,500 over 18837. Get your calculator. We'll have 2.1 uh, 2.0173 plus 0.3557 T in Kelvin. Okay, So we are not finished yet because we are asked to provide the T in degrees Fahrenheit. So we will have to convert. So TK, as you can see, we will have this conversion. Okay, so um, we have TF here, and then just like we will convert this to degrees Celsius. Okay, so we'll convert this to degrees Celsius. So we will subtract it with 32 and then divide it by 1.8, and then we will have to add 273 to it. So remember, this section here is uh, in degrees Celsius. So in degrees Celsius, you just convert to degrees Celsius and then add 273 to it. So it's just actually the same, and just I made it easier for you. Okay, so we will substitute it here. Okay, so substituting, so we have 2.173 plus 0.3557, and then insert this whole expression, f 32 over 1.8 plus 273. So the answer will be 92.8 plus 0.198 times TF. Okay, so that will be the final answer. You just have to simplify this expression here, and then you will get this answer. Okay, that's that easy. So let's move on to the last problem. So heat capacities are usually given in terms of polynomial functions of temperature. Equation for carbon dioxide is, okay, so this long equation, and then where's T is in degrees Fahrenheit and Cp is in BTU per lb mole per degrees Fahrenheit. So convert the equation so that T can be in C and Cp will be in joules per gram mole per Kelvin. So still the same procedure. uh, Convert, uh, make a conversion factor. Okay, so what we have here is a in BTU per lb mole per degrees Fahrenheit. So this is in difference yapon ha. Okay. So 1 BTU is equal to 1055 joules. And then we'll have to convert into gram moles. So 1 pound mole is equal to 454 gram mole. And then uh, this is actually also found in your theories. So 1.8 Fahrenheit is equal to 1 uh, degrees Celsius. Okay, so get the result of your conversion factor. We will have 4.183. It's now in joules per gram mole per degrees. No, no, per, never mind that, per Kelvin. Okay, so same procedure. Multiply it multiply this expression to the uh, whole expression here, multiply our conversion factor to this whole expression, and then remember that we are asked to get the T in degrees Celsius. So let's replace that T with, uh, this is in Fahrenheit, right? So our goal is to have it in degrees Celsius. So TF, so is convert that into degrees Celsius, okay? So what's important there is that we have the degrees Celsius in our expression later. So uh, substitute that here and also here and also here, okay? So you will have so that means that if you will substitute that here, you will have to expand it. So if you can remember your binomial theorem, binomial expansion na lesson, okay? So that the final answer, kung inyo na siyang i-expand and then do all the calculations yourself. So the final answer now will be 36. So I will not show it because it's very lengthy, but here is what I got. So 36.26 plus 0.0423 TC minus 2.886 times 10 to the negative 5 TC squared plus 7.461 times 10 to the negative 9 and times temperature in 3 Celsius cubed. Okay, so that will be our final answer. Okay, so it's that easy. So the calculation may be really long if you want to do it and confirm my answer, but it will be really fulfilling if you do it by yourself. Okay, so I have to give you practice problems. Okay, so this is actually a similar to what I have shown you earlier in the sample problems, and then the last. Please answer it actually in the comments below, and then for the last problem. So this is really a familiar problem. Maybe if you have taken this, so if you have an answer to this, answer it in the comments below. Okay, so that ends my presentation. So thank you. So if you have any questions, you know where to find me. So actually the reference book is Himedla on rigs actually, and basic principles and calculations in chemical engineering. So don't forget to like and subscribe and share this video to whoever needs it, and then maybe you can use this in your future checkout lesson and ace your exams. Okay, so that's it. Bye bye.